we're going to kind of build on what we did yesterday. So a lot of the same thing, we're going to add in the graphing. So with your graphic organizer, okay, you want to fold in along that dotted line. Okay, so it's going to end up looking something like this. So the big words should be on the outside. You should be able to see graphing linear equations on one side. And you can go ahead and cut along those two dotted lines there. And then whenever we get it glued into your notebook, it should look something like this. Go ahead and take a minute to get it folded and cut. Okay, the first thing we're going to talk about today, this slope-intercept form, that first flap there, isn't anything new. That first flap is just what we learned yesterday, okay? The biggest thing, and this is why we started with what we did yesterday, not necessarily starting with graphing. The biggest thing when we are graphing, okay, is it has to be in slope-intercept form. You cannot graph an equation unless it is in slope-intercept form. So let's recap what we talked about yesterday. Okay? As a reminder, to put an equation in slope-intercept form, you solve the equation for y, use the onion method if you find that helpful. So like this first one here, to put it in a slope-intercept form, if I wanted to solve for y, I would just need to get rid of the 2x. So I would subtract 2x from both sides, and we would get y equals negative 2x plus 5. And remember, you don't have to put it negative 2x plus 5 if you wanted to say 5 minus 2x. Mathematically, that's the same thing. But whenever we're identifying the slope and the y-intercept, it's consistent and it's a little easier to pick out the slope and the y-intercept if you get in the habit of writing the y first, or writing the x first, okay? All right, so this one takes a couple extra steps, but if you notice, a lot of the ones you did yesterday, usually the first thing you want to do is move the x term. So since it's a positive 3x, we'll subtract 3x, and I would still have negative 2y equals. We're going to write the x first, and we have negative 3x plus 4. And just like we did yesterday, to get rid of the negative 2, we would divide everything by a negative 2. And then remember, we do the butterfly method here. So I would take negative 3 over a negative 2. A negative over a negative would give me a positive 3 halves x. And then we would take 4 over negative 2, which would be your minus 2. Okay, so that's what we did yesterday. So today what we're going to do is we are going to do that, and then we're going to graph the equations that you get. Okay, so graphing linear equations. Okay, super simple. 3 steps. Okay, well, kind of 4. Okay, first thing, you got to write the equation in y equals. That's the number one thing. It has to be in y equals. Okay. Next thing we're going to do, okay, to graph a line, you need 2 points. 1 point, just by looking at the equation, you'll be able to know a point on the line, and that's the y-intercept. If you remember, we have M and B. B is the y-intercept. The y-intercept is a point on the line. Okay, so you're going to plot the y-intercept. And then, you remember we talked about slope on Monday, how slope is rise over run, change in y over change in x. Then you're going to use the slope to plot the second point. So let's graph this equation right here. First thing, notice it's not in y equals, so I would need to put it in y equals. So let's move the x term by subtracting x from both sides. I'd have negative 3y equals negative x plus 12, okay? And then divide by negative 3, and we would get y equals. Okay, and we're going to do the butterfly method. Now remember we talked about these ones yesterday. First of all, a negative over a negative is going to be a positive. We also talked about yesterday that if you leave it as x over 3, it might be a little confusing what the slope is. So what we did with these ones is we wrote the 1 in front of the x, and we kicked the x out of the fraction. We're going to call it a 1/3 x. And then we would have 12 over negative 3, which would be a negative 4. So what we did yesterday is once we have it in y equals, we said, okay, the slope is going to be the number in front of x, which is going to be 1/3. The y-intercept is going to be that other number, which is negative 4. So far, nothing new. Okay? Now, whenever we're ready to graph the line, this is the hard part. Putting in y equals, that's the hard part. That's what you guys did yesterday. To graph the line, it's super easy, guys. But the biggest thing, okay? You start with your y-intercept, okay? The y-intercept is a point on the line. The y-intercept for this line is -4. That means that this line crosses the y-axis. Okay, the y-axis is the one that goes up and down. This line is going to cross the y-axis at -4, down there. That's where this line is at. Okay, that's a point on your line. Now, I need 2 points to make a line. That's one of them. To get the second point, we're going to use the slope. So remember, whenever we talked about slope on Monday, I said, okay, a slope of 1/3. First of all, it's a positive 1/3, so I know this line's going to slope up. And secondly, it's not a very big number, so I know it's not going to be a super steep line. And we also talked about how slope is rise over run. So whenever you have a slope of 1/3, it means that you are going to rise 1, run 3. Okay, now here's the thing. Anywhere on this line, anywhere on the line, doesn't matter where you start. If you start on the line and go rise 1, run 3, you're back on the line. Anywhere, right? You start over here, rise 1, run 3, over here, rise 1, run 3, anywhere on the line. And here's the thing. That's where my line's at. Right there. So at this point, I'm going to rise 1, run 3, and I'm back on the line. And once you have 2 points, you have your line. Notice it slopes up. It's a positive sloping line. And, like I said, it's not really that steep, right? It's not a very steep line. Okay? That's how we graph lines. Now, the last thing in this foldable are some special cases. Mentioned talking about these on Monday when we talked about slope, but I kind of ran through these really fast. Okay? Sometimes you're going to have lines that are a y-only line. And if you have to graph a y-only line, and I mentioned this on Monday, what you can do to remember this, okay, because the y-only line and the x-only line, one of them goes this way, one of them goes this way. I understand why it's confusing because the y-intercept goes this way, so you might think that the y-only line is vertical, but it doesn't work that way, okay? When you say why, you're like, why is math class so fun? Why can't I have math every hour, right? When you say why, what do you do with your arms? Okay? So when I ask you to graph a y-only line, you do that with your arms. And you think it's silly, but whenever you guys take your quiz over this, you'll be sitting at your desk and be like, why? You'll look around and be like, oh yeah, this. Okay? So, a y-only line is a horizontal line. Now, how you're going to decide where to draw this horizontal line, okay? It kind of tells you. On your y-axis, at 4. 1, 2, 3, 4, okay? That's where you're going to draw your horizontal line. These lines are easy to draw, okay? The x-only lines are the opposite. And I mentioned on Monday, think about x like an axe, right? They both got x's in them, okay? And then an axe goes like this, okay? So this is going to be a vertical line. And you do the same thing. On your x-axis, at -2, that's where you're going to draw your vertical line. So those are the 2 special cases that you can graph. Okay, all right, let's get this glued into page 39. Okay, this is still section 5.3, and we'll call it Graphing Linear Equations. Graphing Linear Equations. All right, so here we go. Number 1, -4x plus 3y equals 9. -4x plus 3y equals 9. Okay, first thing, it's so incredibly important. It absolutely has to be in y equals. So this is the exact same thing we did yesterday. We need to move the x term first. This time, since it's a -4x, we're going to add 4x to both sides. So I would have 3y equals 4x plus 9. Remember, guys, this is an x term. The 9 is not an x term. You cannot combine those together. Okay? And then to get rid of the 3, we would divide by 3y equals, and just like yesterday with the butterfly method, we'd have 4/3 x, 9/3 would give me a plus 3. Now I'd like you to do everything we did yesterday, so even after we do this step, let's go ahead and say, okay, the slope is 4/3, the y-intercept is 3. Because to graph this, that's all I need. To graph this, I just need the slope and y-intercept, okay? When you're ready to graph, the first thing you graph, and this is so important and probably the biggest mistake I see, the first thing you graph is the y-intercept, because the y-intercept is a point on the line. Okay, now let's talk about this. The y-intercept, the y-axis is the one that goes up and down. So since my y-intercept is at 3, it means I'm going to have a point at 3. That's the first thing you do. Put a point on your y-axis at 3. The next thing, my slope is 4/3. Remember, slope is rise over run. So this means anywhere on my line, I can rise 4, run 3, and I'm back on the line. Here's the thing, guys. You have to start on the line, okay? The y-intercept is a point on the line. So from this point, I'm going to rise 4 and run 3. So we're going to go up 4, maybe, and over 3, and we have our line. Okay, now, here's what may happen on your homework. Okay, on your homework, since the graphs are drawn for you, what may happen is you may plot your y-intercept at 3, and then when you go up 4, it may be off the graph, which is not a huge deal. You could kind of estimate, but what I'd like you to do is try to get your points to fit on your graph. So what you can do, okay, if you go up 4 and write 3, and it takes you off your graph, what you can do, guys, this line extends in both directions. So you could plot a point up and to the right, but if I wanted to plot a point down here, you can do that. What you have to do is you have to switch both directions of your slope. So for the slope, instead of going up and right, you're going to go down and left. See how that's still on my line? Okay, so we're going to practice that because that's going to come up on your homework a lot. Okay, let's try another one. Number 2. Negative 6x minus 5y equals 10. Okay, first thing, it absolutely has to be a y equals. So I'm going to move the x term. I'm going to add 6x to both sides. So you'd have negative 5y equals 6x plus 10. And then to get rid of the negative 5, we would divide by negative 5. So we would get y equals, and then I would take 6x over negative 5, which I can't reduce, so we'll call it a negative 6 over 5x. And then we'll do 10 over negative 5, which is negative 2. Okay, so the slope, just like we did yesterday, is negative 6/5. The y-intercept is negative 2. So I need to start with a point. Yeah, so I need to start with a point on my line. This right here is a point on your line. You are always going to start with your y-intercept first. You're going to plot on your y-axis a point at negative 2. Okay, now let's talk about your slope. Because my slope is negative 6/5. Here's the thing. If your slope is negative, what should your line look like? It should be going down, okay? How you are going to make your line go down, okay? This negative sign, whenever we're thinking of rise over run, this negative sign, guys, can either go in the numerator as negative 6 over 5 or the denominator. And I'll show you that both ones are going to get you the same answer, okay? So you either put the negative in the numerator, which means you're going to rise negative 6, but you're going to run positive 5. Or you can rise 6, but run negative 5 by going to the left. You can do either one. It doesn't matter. Okay, so watch this. If I rise negative 6, I'm going to go down 6, and then run. Notice the 5 is in the positive direction, so I'm still going to run 5 in the positive direction. That's where that point would be. But I want to show you guys. If instead you rise positive 6, and run negative 5 by going to the left. Look, guys. Even on my kind of sketchy little graph here, they're on the same line. It doesn't matter. The negative can go with the numerator or the denominator. What you cannot do is do negative 6 over a negative 5. You cannot go negative in both directions. Because watch this. If you were to start here and go negative 6 and negative 5, that's not on the same line, right? And in fact, isn't that a positive line? Which should make sense. Because what's a negative over a negative? A positive. Okay? So this is the only thing you cannot do. Okay, does that make sense? Okay, let's try another one. Number 3, x minus 4y equals negative 8. Okay, it absolutely has to be in y equals, so we're going to move our x term. So I'd have negative 4y equals, and then I'm going to do negative x minus 8. Okay, whenever I divide everything by negative 4, we should end up with y equals. Okay, I have negative x over a negative 4, a negative over a negative is a positive. And remember, with this x over 4, don't leave it as x over 4 because it's going to be confusing. We write the 1 in front of the x and kick the x out of the fraction, so we have a 1/4 x. And then we have negative 8 over negative 4, which would be a positive 2. So this line has the slope of 1/4 and a y-intercept of 2. Slope of 1/4, y-intercept of 2. So the first thing I plot is that 2. On your y-axis, remember the up and down axis, you're going to put a point at 2. Then my slope is 1/4. So we're going to rise 1, run 4. So rise 1, run 4, and put a point. Now remember, if you wanted to plot a point over here in the other direction, switch both. Instead of rising up 1, go down 1. And instead of running to the right, you run to the left. Look, down 1. You can swap both directions and see how they're on the same line there. You can always do that. Okay. Number 4. 16x minus 4y equals 12. What's my first task here at hand? Yeah, subtract the 16x. It absolutely has to be in y equals. So we have negative 4y equals negative 16x plus 12. Divide everything by negative 4. We should end up with y equals negative 16 over a negative 4 would give me a positive 4x. And then 12 over negative 4 would give me a minus 3. So the slope of this line is 4. Now here's the thing. Whenever you have a slope, it's not a fraction. Just keep in mind, slope is rise over run. It's really, really handy when slope is a fraction. But 4 is not a fraction, but I can write it as a fraction. What's 4 as a fraction? 4 over 1. I would really, really encourage you guys to always write your slope as a fraction, even if it's not. Okay? And then the y-intercept is at negative 3. What's the first thing I'm going to plot on this graph? Negative 3. 1, 2, 3 down here. And then my slope, since I wrote it as a fraction, means I'm going to rise 4, run 1. Up, 4, right 1. Okay, let's talk about some that look a little different. Just a few more, guys. Number 5. Okay, this one says 4x minus 3y minus 12 equals 0. Now this one's different because how they've always been written is the x's and y's are on one side and then the constant is on the other side. And this time everything's on the same side. So I probably don't do this the easiest way, but I'm kind of like a big routine person. And I just like to keep the y on the left and move everything to the right. So in this case, what I need to do, I need to move the 4x and I need to move the minus 12. So if you want, you could do that in the same step. We're going to subtract 4x from both sides. But I also need to move that minus 12 to the other side, so I'm also going to add 12 to both sides. So we would have negative 3y equals, and on the right-hand side, we'd have negative 4x plus 12. And then once you get to this step, it's the same. Divide by negative 3. We would do the butterfly method. A negative 4 over a negative 3 would be a positive 4/3. 12 over negative 3 would be a negative 4, which means my slope is 4/3. My y-intercept is negative 4, and hopefully we're kind of catching on to this. We always plot the y-intercept first, so I'm going to have a point at negative 4. And this time, since my slope is 4/3, we rise 4 and run 3. Okay, now this one I know always gives students a hard time. Okay, so you're gonna have one like this on your homework. Let's do y minus 5x equals 0. Y minus 5x equals 0. Okay, get it in y equals. Really, the only thing I need to do is add 5x to both sides. And then it says y equals 5x. 0 plus 5x is just 5x. If you want, you can put plus 0 there. You don't have to. What's my slope? 5. Or as a fraction? 5 over 1. What is the y-intercept? It's 0. So if you wanted to say 5x plus 0, that might help you identify your slope. You'd be more than welcome to do that. You don't have to. Okay? So how do I plot a y-intercept as 0? Yeah. It's just right there, right? And then from there, remember the slope is 5 over 1. So make sure you rise 5 and run 1. And last two, and these are easy ones, should be easy ones. X equals 3. X equals 3. What does an X only line look like? Everybody's going to have to do it. X only. X like an X. Everybody's got to do it. Everybody's got to do it. X like an X. It's a movement thing. Everybody's got to do it. I'm not going to move on until everybody does it. X like an X. X like an X. Yeah? All right, I'll take it. Okay, so I know this is going to be a vertical line. This tells you where to draw it. On the x-axis at 3, that's where you draw your vertical line. Okay, and then what about y equals 5? Okay, show me. What does a y only line look like? Y. I'm not going to move on until everybody does it. Y. Don't you guys have as much energy as I do this morning? Y. Come on up, friend. Y. Thank you. Y only line looks like this. So on your y-axis at 5, there's your line.